Hi friends, in this video we will see how to configure bridge domain on a Juniper device. In the previous video we saw how to configure bridge domain on Cisco device. So the same scenarios and the same topology we will now this time configure for uh, Juniper device. You can download this PDF file using the link in the description. So let's get started. Here now again, what is a bridge domain? Bridge domain represents a layer 2 broadcast domain. Now the question is, why do you need it? Among many other use cases, so two of them are: number one, enable VLAN support on non-VLAN capable devices. So now imagine this R1 here does not support VLANs like a Juniper MX router. So in this scenario, if I have a switch 1 and a switch 2 connected to this router R1, and these ports on the switches are layer 2 ports, how can I switch the traffic between these switches via R1? So we can use bridge domain. Bridge domain, literally it can bridge these two ports like this, okay, so that you can carry the layer 2 broadcast domains between these ports. And another major benefit of bridge domain is overcome VLAN scale limitations. Switch VLAN namespaces are capped at 4096. Moving the VLAN ID from a per switch to a per port basis significantly increases flexibility. So please take note of this. The VLAN tags we will configure for the bridge domain, they are significant per port, not per box, okay, and reducing the number of individual VLANs required. This is especially valuable in VXLAN networks where VLAN limits become a constraint. So now let's look at our topology for this session. Switch 1, switch 2, R1, R2, they are all Juniper devices. What we are going to learn in this video, so same scenarios which we configured for Cisco, and here we will configure for Juniper. So first of all, we will enable the communication between switch 1 and switch 2 using an untagged VLAN. Means the VLAN 10 will be untagged on these ports, okay, and we will see how to configure the bridge domain here on R1 to handle untagged layer 2 traffic. Then in the scenario 2, we will configure these devices so that switch 1 and switch 2 can communicate using a tagged VLAN 20 here on these ports, okay. And then on this, in the scenario 3, we will configure the VLAN 30 only on this port on switch 1, only switch 1, and the VLAN 40 only on switch 2. It means that we will now need inter VLAN routing here on R1. We will see how to configure that, and we will run OSPF on it, and more we will also configure this external link between R1 and R2 so that switch 1 and switch 2 can communicate to this with this R2 device. So let's look at the scenario 1. So here we are going to configure the switch 1 and switch 2 for our task 1, which is communication between switch 1 and switch 2 using an untagged VLAN 10. So that's how you enter the configuration mode on a Juniper device. So from the operational mode, you write this command configure and you enter the configuration mode. So here we will first configure the VLAN, set VLANs, and this is the name of the VLAN, just name, and the VLAN ID and actual number. And then we will also bind an L3 interface IRB.10. So it's like an SVI in Cisco. So this is the layer 3 interface IRB, integrated routing and bridging. So set interfaces IRB unit 10 and INET address. So it's like you configure an SVI for this VLAN and you bind this IRB.10 with the VLAN, which means that now this interface is the layer 3 interface for this VLAN. And next what we will do is now we will configure the physical interface, set interfaces XE0/0/1, because this is an untagged VLAN, so we have to use the word native VLAN ID. And then on the port we will configure the Ethernet switching family because it's a layer 2 port, interface mode, and then we will pass the VLAN here, family, Ethernet switching, VLAN members, and the VLAN 10, commit and quit. So here please note that 10.1.10.x means 1 you will use for switch 1 and .2 you will use for switch 2. Here I have mentioned that. So now let's see how to configure our R1. So on R1, on this interface 0/0/1, we will enable flexible VLAN tagging because we are using untagged VLAN as well as tagged VLANs, and we will enable encapsulation extended VLAN bridge, and then the VLAN ID, the native VLAN ID on this port here, and then the unit 10 VLAN ID. So don't get confused with this unit thing. It is like if you are coming from Cisco, it's like a sub interface, and you don't have to match this ID with this ID. So now on the same thing we will do on GE0/0/2, flexible VLAN tagging, extended VLAN bridge, native VLAN ID, and the VLAN tag. And now we will configure the bridge domain. Now here on Juniper, there are different ways to configure the bridge domain for this particular scenario. Okay, I am just using this way, which I think is simple and more in line with our particular requirements. So set bridge domains is just the name VLAN 10, and we will mention the domain type is bridge. And here I'm just using the VLAN ID none. If you use the VLAN ID 10, it will still work, but I don't need, because here on the actual port I am already having a different sub interface per VLAN. So I can simply ignore the VLAN ID, and then I will bind these two sub interfaces in that bridge domain. Commit and quit. Now let's do the verification. Now if you ping from the switch 1, now if you ping switch 2 from switch 1, the ping is successful. Now how it looks like on R1, show bridge MAC table bridge domain VLAN 10, and you can see these MAC addresses. So these MAC addresses are the IRB interfaces MACs on switch 1 and switch 2. Now let's look at the scenario number 2. Communication between switch 1 and switch 2 using a tagged VLAN 20. Same thing. Now this time all we have to do is we just need to configure the VLAN. Its layer, we will bind the layer 3 interface for this VLAN, and we will configure the layer 3 interface. For switch 1 we will use .1, for switch 2 we will use .2, and then we will simply allow the VLAN on these ports, switch 1 and switch 2. We will commit and quit. Now let's see how to configure R1 for this. Similar, we will just configure an other sub interface on these ports. Set interfaces, interface name and type, and then unit, VLAN ID, and same thing on this interface. And now the bridge domain, and here the bridge domain type, we can use the same VLAN ID none, and we will bind the sub interfaces here and commit and quit. Now if we ping switch 2 from switch 1 for this VLAN, you can see the ping is successful, and you can check the bridge domain table. These MACs are for the IRB of switch 1 and switch 2. Now let's look at the next scenario. Now here we are going to use VLAN 30 only on switch 1 and VLAN 40 only on switch 2, and we will also enable OSPF, and then we will also configure the OSPF on these ports. So here again same thing, on switch 1 set VLANs, its IRB interface, we will bind it with the VLAN, and then we will configure the layer 3 interface for the VLAN, and then we will allow the VLAN on the port. You don't need this command here, as we already have configured this port as a trunk port, so you don't need this command here. You can just allow the VLAN on the port, this one, and that's how you configure the OSPF protocol for this layer 3 interface. Set protocols OSPF area 0 interface IRB.0, commit and quit. Similarly on switch 2 we'll do the same thing using VLAN 40. Okay, again you don't need this command, we already configured it, and now again we will configure the OSPF, commit and quit. Now let's see how R1 looks like. So here you can see on R1, first of all we will configure the sub interfaces for the VLAN 30 and 40, and I am configuring separate bridge domains for each sub interface. This is for the VLAN 30, which is towards switch 1 here, and this is for the VLAN 40, which is towards this switch 2. And in the same way we attach the sub interface on the physical port, and the IRB interface, and similar for the VLAN 40. And now here we will configure the IRBs for VLAN 30 and 40, because now we will configure OSPF on these ports on R1. So we need an IP address on R1. So this IP address is towards switch 1 and this IP address is towards switch 2. And here this port is toward the external network. We will also configure an IP on this port, and here we just configure OSPF in area 0 for all these ports, IRB 30, IRB 40 and the external network. And here you configure the R2 router. Simply set interfaces, the unit, the family, INET and then the address, and we will enable the protocol's OSPF on the port. Now if we ping from switch 1 to switch 2, you can see the ping is successful. If we ping R2 from switch 1, you can see the ping is successful. And here the OSPF neighbor on R1. So you can see they're all full state. Now next, let's see a challenge question. So here is a challenge for you. Now imagine if you configure the VLAN 50 on switch 1 and VLAN 60 on switch 2. And here notice I use the same subnet 50.1, 50.2 on switch 2. Can you ping from switch 1 to switch 2? And here you will configure a bridge domain. Towards switch 1 you will use a sub interface .50 with the VLAN ID .50, and towards switch 2 sub interface with the VLAN ID .60. So the question is, can you ping between these devices using this weird design? So this is to test your knowledge about the topic. Feel free to let me know your opinion in the comment section, and thank you.